Yes, student. Today I will explain you the application of Fourier transform to boundary value problems. Okay. Now, so let f of sine transform of del 2u by del x2 is equal to 0 to infinity. This is the definition of the sine transform. 0 to infinity del 2u by del x2. This is the function sine px dx. Okay. Now integrating by parts. Yes. Taking this to the second and this to the first term. So we get, yes, del u by del x sine px, and now differentiation of sine px, which is cos px, so minus of p cos px. Okay. Now del u by del x tends to 0 as x tends to infinity. So, and also at 0 sine px, this is again 0, so you get the value is only minus p and 0 to infinity del u by del x cos px. Okay, students. Now again integrating by parts. Okay, if you again integrating, this is then here is p minus p is again here, and if you integrating here, then this is u. Okay, and also the integration of this is, yes, integration of this is, that is the u, and also the sine of this is. Okay, again integrating this, we get minus of p square u sine inverse of pt. Okay, now because we have earlier minus of p, yes, and if you integrating this, then u cos px 0 to infinity plus p. Okay, and u sine px. Okay, and actually here you see this is minus of p, u at a point 0. Yes, and now this term, actually this is the sine of Laplace Fourier sine transform. So you substitute here is, this is p, and again so you say that this is the p minus p is here, p is here, so this is minus p square, and this is the sine transform or sine transform. Okay, yes, clear? First equation. Now where uxt be the function of the variable x and t, and u bar spt will be the Fourier sine transform of uxt with respect to, yes, x. Okay, now also for the cos transformation, if you see, okay, f of c of del 2u by del x2 for a cos transformation according to definition. This is this one. Yes, clear? And now you apply the definition, you further integrating. Okay, as you will earlier, here you are integrating, similarly you integrate here, then first integrating del u by del x cos px 0 to infinity, here is again. Okay, now this become del u by, because as cos 0 is which is equal to 1, so we get the value is del u by del x tends to 0, x tends to infinity, so at a part the 0, this is 1, and this is become the minus of this is this for limit, minus of this limit, so minus of this is, and this is this term. Yes, clear? Now okay, this is good. Minus del u by del x, x barabar 0, plus p, and r. No, also further integrating, this is u sine px 0 to infinity minus p u cos px dx. Is clear? Okay, as u tends to 0, as x tends to infinity, so this term again be written as, yes, p square, here is p square, this term becomes 0, so here is minus p square u, this term xt, and cos px dx. Yes, clear? Okay, so the f of c del 2u by del x2 is equal to minus del u by del x at a point x is equal to 0 minus p square, and this is cos transform of, yes, cos of for the function u, so u bar c pt, equation number 2. Yes, clear? Okay, students. Now here, yes, here where UC cost वाला PT is the Fourier cosine transformation of uxt with respect to xy. From equation 1 and 2, the Fourier sine transform requires the value of u0t, whereas the Fourier cosine transform requires the value of del u by del x at a point x barabar 0. You see here, because here is you require value ux0, okay, for the sine transformation, and also for here del u by del x for x is equal to 0. You see this one. Okay, students, clear? So in this way you have to find the application of Fourier transform to boundary value problem. Yes, students, clear? In the next video I will define you some finite differentiation. Okay, students, thank you.